In Ccna, one of the important topic is IP address. Importantly, you need to know about IP address. Okay. So IP addressing is a logical addressing which is implemented at layer 3, which is network layer. We have OSI model which has several layers. We will have OSI model in a different video. In order to identify our network devices, we use IP addresses. So there are two types of addresses. One is IP address and other one is MAC address. In IP address, we use 32-bit IPv4 address, which is IP version 4 address, or else 128-bit IPv6 address, IP version 6 address. And we have MAC address, which is 48-bit. Before we begin IP addressing, we need to know about binary to decimal conversion and decimal to binary conversion. In this page, you can see I have used 8 digits to represent 0 to 255. So from 0 to 255, you can represent by using 8 bits, by changing ones and zeros. Okay. So from the right side corner, you will start from 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 5, 6, and so on. It goes as 1, 2, 4, 8, 16, 32, 64, and 128. So any number you place here will be multiplying the place value. Okay. So if you have 0 here, 0 multiplied by 1 gives you 0, and 0 multiplied by 2 gives you 0. Likewise, 1 multiplied by 64 will give you 64, and 1 multiplied by 128 will give you 128. So altogether you will have 128 plus 64, which is 192. And if you want to write 168, you can figure out you might need 128, so you add 1 in the 128 place, and you don't need 64 further. If you add 64, it might exceed the value of 168. Okay, so you are going to add 32 and 8, so totally you will have 168. If you add 128 and 32 and 8, totally you can have 168. So by using this way, you can represent any number from 0 to 255. Okay. So if you want to write 1, you can represent only 1 in the ones place value, and all others you are mentioning as 0. Okay. And if you apply ones for all the 8 bits, you will get 255 in total. Okay. If you apply 0 for all 8 bits, you will get 0 as a result. It's better if you can remember from 2 to the power 0 to 2 to the power 10. Values are given here, you can check. And next, converting binary to decimal. Let's say if you are having 8 bits and you mention first 2 bits as ones and the remaining as zeros. So what is the answer is, first one will represent 2 to the power 7 and the second one will represent 2 to the power 6. In total, 2 to the power 7 is 128 plus 2 to the power 6 is 64. So you will get 192. In a basic network environment, you will have switches and end devices and routers like this. For example, let's say in your company, up to here is branch 1 and up to here this is called branch 2, for example. So in each switch, you will connect end devices, which are PCs, laptops, servers, printers, IP phones, whatever. All these are called hosts. And for one particular switch, you can connect all these end devices and make them communicate with one another. But you can't communicate from one network to another network. which means each switch is assigned to a specific network. And there are some other technologies you can use to communicate from one network to another network. Okay, so when we are going to do our IP calculations, you need to know what are networks and what are hosts. As in our previous explanation, we found that by using the binary value, you can represent numbers from 0 to 255 by using the 8 bits. And in our IP address, you will have altogether 32 bits in IPv4 address. So by changing ones and zeros, you will have 4.3 billion combination of addresses, which means you will have 2 to the power 32 bit addresses. Okay, so in that we are going to specify number of networks and number of hosts in each address by changing ones and zeros. Okay, in our 32 bit of IPv4 address, we are using ones to specify the network portion and zeros to specify the host portion. So we can simply figure out how many networks we can implement by using this IP, and also how many hosts we can attach to this particular networks. In our IP address, you will have class A, class B, class C, class D, and E. Class D is used for multicast addressing, and class E is used for research purposes. Class A, B, and C in our IPv4 calculations. In class A, the first 8 bits are going to be network bits, and the remaining 24 bits are going to be host bits. And in class B, the first 16 bits are going to be network bits, and the remaining 16 are host bits. And in class C, as you can see, the first 3 octets are going to be network, and the last octet is going to be host. Since it's 8 bits on each set, we are going to call it as octets. First octet, second octet, third octet, and fourth octet. As I explained earlier, if all the 8 bits are ones, you will get the value of 255. And in network portion, we are using ones to represent networks. Class A, the first 8 bits are going to be ones, and it is network portion, so it will give 255 in decimal. Okay, so that is why we are specifying 255 here, and the remaining host portions will be represented as all zeros, so we mention it as here. And in this form of writing 255.0.0.0 or 255.255.0.0 or the other one, all these specifications are called as subnet mask. We use subnet mask to specify the number of networks in our IP address, and the next /8 and /16 and /24 value are called CIDR, classless interdomain routing, which is also used to specify how many bits in your IPv4 address is going to be your network bits or going to be your ones in your 32-bit address. Okay, so in class A, the first 8 bits are going to be network bit, so we will mention /8. In class B, the first 2 octets are going to be network, so 16 bits, so here we will mention /16. And the class C /24, you can figure it out. For example, if I am having a company which I need only around 255 networks, I can go for class A, where I can get 2 to the power 8 networks, which means obviously 256 networks I can have. And in class B, I can have 2 to the power 16 networks, and in class C, I can have 2 to the power 24 networks. So from class A, if that company needs to increase their network, they can go for class B by borrowing the next host portion into network portion, by changing their second octet host portion into network. And if they wanted to increase further, they can try converting their third octet of host portion into network, by which leaves them into class C. But you can notice whenever they increase their network portion, their host portion is going low. It will decrease. So you can figure out from class A, if I wanted to increase my network, I can change my second octet into network portion. So as a result, I can have 2 to the power 8 more networks in my company, but which will result in reduce of 2 to the power 8 host portions missing in my company. So there are instances I might need to increase my networks, but I don't want to reduce my hosts in a large amount. So only a few increment in network size is enough for me. So at that time, I can't prefer this way of approach. So what I have to do is, I have to borrow only few bits of host portion and change them into ones, which means convert them into networks like this. Okay, so this method of approach is called classless subnetting, and the previous one we call it as classful. Okay, where we borrowed all complete 8 bits into network side. And now we are going to do, what we are going to do is, we are going to borrow bit by bit as per our network requirement. So in this case, I will have only 2 more network bits, which means 2 to the power 2, 4 networks extra in addition. At the same time, my host portion is not that much reduced as before. I still have 2 to the power 6 bits of hosts remaining in the second octet. While borrowing number of bits like this, you need to borrow bits continuously. You can't borrow one here and the other one from another octet or from anywhere without continuity. So you need to borrow, if you want to borrow 4 bits, you need to borrow the continuous 4 bits. If you want to borrow 3 bits, you need to borrow continuous 3 bits. And if you want to borrow 8 bits, you can borrow continuously the 8 bits, not the 8 bits from here, by leaving these bits as zeros. Okay, so let's try to work out on IP address calculations. So first of all, you need to know how the IP address flows. It's starting as 0.0.0.0 and ends in 255.255.255.255. Okay, if you have used a digital watch, you can simply figure out how the IP addresses are working. So in the seconds portion, we will have 60 seconds, and in minutes we will have 60 minutes, and from seconds it increases from 0 to 59. After 59 it moves on to 0 again, and the minutes will increase by 1. Okay, again it flows from 0 to 59, and while remaining 1 in the minute portion. After reaching 1 minute 59 seconds, again it moves as 2 minutes 0 seconds. Okay, likewise it flows. In order to have an increment in the hours portion, you need to have both minutes and seconds column filled with 59, right? Think like it's a water bottle and you are filling it from right side. So first the initial first bottle must fill, and after filling it, the remaining extra water will start filling the second bottle, and then again after filling the second bottle, the third bottle will start filling. Likewise, our IP address is going to flow. So 0.0.0.0 is our first IP, and it increases from this fourth octet 0 to 255 until 255. It increases continuously. After reaching 255, the next column will become 1, and this fourth octet will become 0. After reaching 255 in the fourth octet, the third octet will become 1 and the fourth octet will become 0. Again, until 0 to 255, the fourth octet will increase one by one while maintaining the third octet as 1. Then, after reaching 255, the third octet will become 2 and the fourth octet will remain as 0. And the process continues. Once the both third and fourth octets becoming 255, the second octet will become 1 and the third and fourth will become 0. And the next IP is 1.0.1 and the other one is 1.0.2. Likewise, it increases one by one. You can figure out the IP flow here, 0.0.0.0, and it's increasing by 1, then 2, 3, 4, likewise up to 255. Then the next octet will become 1 and the current fourth octet will become 0. Then again 1.1, 1.2, 1.3, likewise it flows up to 1.254 and 1.255. After that, next 2.0 and 2.1, 2.2 and 2.255 and 3.0 next and 3.255 in a process. Likewise, you will have 4.0, 4.255, 5.0. Likewise, you will have 255.0. Then you are going to have again 255.1, 255.2 and 255.255 in a sequence. Then the next IP address, can you guess it? 1.0.0. So once the 255 is reached means this bottle has become full. After full, it's going to fill the next bottle. So, and here how many 255s are there? Altogether 2 255, which means the 2 bottles are filled and it's going to start filling the third bottle now. So this is how it happens. Okay. So 1.0.0. Again, the next IP is 1.0.1 and this one continues up to 255. Once after reaching 255, it's going to increase 1.0 and 1.255 likewise. After reaching 255.255, the 1 will again become 2. So if an IP is given, you need to know how to write the next IP and the previous IP. Like here, let's say for example, if I'm asking you to write 0.0.255.0. So I wanted you to write the next IP of this one and the previous IP of this one. So let's start writing the next IP first. First of all, you need to start from the right side. If there is 0, there is no issues. You can simply add 1 because the bottle is not full yet. So it goes up to 1, 2, 3 and up to 255. Once if you figure out 255 here, you need to add 0 there. Okay, which means 255 means the bottle is full, so you need to make it 0. And all the remaining here, you have changed this 0 into 1 next IP because the bottle is not full, and all the remaining 3 octets will remain same. 0.0.255.1. And we are going to have a look at the previous IP for this IP now. So from here, if you are having 0 means the previous one should be definitely 255. That you can figure it out. Okay, whenever you see a 0 here, the previous IP will be 255 because after 255 only the next IP will become 0. Okay, and in this case, if you move on to 255, which means your next octet, third octet, is going to be 254. Why? It's going to deduct 1 from the current IP, current value. It's going to deduct 1 from the current value. So it's 254. So you can figure out 0.0.254.255 will be the previous IP of this 0.0.255.0. Okay. If you have any doubts, you can comment or ask me by mail. So in our subnet mask, you can figure out if you have 1255, you will have /8. If you have 2255, you will have /16. Which means if you know the subnet mask, you can write the CIDR, or else as vice versa, if you know the CIDR, you can write the subnet mask. /16 means you can simply calculate there are 2 octets going to be 255. So you have written this. You can write this. All these you can specify for a class full. 255s and zeros are only involved. But if you borrow bits like as a portion, only 2 bits you have changed into network side. So how you can write the subnet mask? Let's have a look at it. If you borrow 2 bits in this chart, you can figure out 128, 192, 224, 240, 248, 252, 254 and 255, which is flowing from left to right. If you borrow only 1 bit, you will have 128 in your subnet mask octet. And if you borrow 2 bits, you will have 192. If you borrow 3 bits, 224, 4 bits, 240, 5 bits, 248, 6, 7 and 8 bits borrowed means 255. Okay, so let's have a look at this example. In this, you already have 8 bits as ones and the remaining as 0. And now you are converting the next 2 bits into network side. So your first 8 bits are going to be 255 dot, and the remaining 2 bits, if you borrow 2 bits as per our chart, 2 bits borrowed means 192. So your subnet mask will be like 255.192.0.0. Okay, and your CIDR will be like altogether 10 bits are network bits now, so /10. Okay, by using these methods, we are going to do our IP calculations. So what they specify in our network is, as per in this diagram, you can see 250 hosts for LAN 1 and 100 hosts for LAN 2, which means they will tell you the number of hosts requirement per subnet, or else they can tell you number of subnets they need, and you have to do the remaining calculations. Okay, so let's have a look at it one by one. In order to do my calculations simpler, I use a jargon NH mask multiplier networks, which has 4 portions. NH is the first portion, mask is representing subnet mask, multiplier is going to represent in each subnet how many addresses are going to take place, and networks will represent what are the networks or subnets I can have in my IP. So we can approach the question one by one and work out. So for example, let's take an IP address 172.16.0.0/16. This is the IP address I'm going to do my calculations, and the question is minimum 120 hosts per subnet. Okay, so let's do the question now. So this is my IP 172.16.0.0/16, and my requirement of host is 120 hosts per subnet. So my first jargon is NH, which means if they are asking about number of hosts, you will go for H, and if they are asking about number of networks, you will try N. So here they have specified hosts, so I'm going to use the H, which means 2 to the power H greater than equal to 120 addresses plus 2. So here I'm adding 2 as per my network address and broadcast address. If they wanted 120 hosts, means the 120 addresses are going to place for the network devices. In each subnet, you will have a network address and a broadcast address. The first address is going to be the network address, and the last address is going to be the broadcast address. So for that purpose, in any question like this, 120 hosts or 80 hosts or 40 hosts or 400 hosts per subnet, whatever, you will add 2 into that host number and do the calculations. But in case if you are having a question like number of networks or number of subnets required, then you don't need to add this 2, which we will do in a later session. So for right now, I'm going to answer 120 hosts per subnet. So 120 plus 2, totally 122. So 2 to the power H greater than or equal to 122. So 2 to the power how much will give me 122 or greater value. So you may know 2 to the power 5 is 32, 2 to the power 6 is 64, 2 to the power 7 is 128. So I can choose 2 to the power 7, and also 2 to the power 8 is also greater than 122. But I can't choose it. If I choose it, it will give me a large amount of hosts, which I don't prefer. We need to save IP addresses when subnetting. We can't waste IP addresses. So what I can choose is the best possible value 2 to the power 7, okay, which is closest to this value. So 2 to the power 7 gives me 128, which is greater than 122. Okay, so in my NH, the first part has been done. Next, mask, which is subnet mask. Okay, so in order to write the subnet mask, I need to know how many network bits are going to take place in my IP address. So I have figured out H equals 7 means number of host bits are going to be 7. So as you know, in my IP address altogether I will have 32 bits and 7 bits are going to be host bits, means the remaining bits are going to be network bits. So 32 minus 7 will give me 25, which is my network bits. If you have any doubts or confusion, please comment or send me an email. I will reply. So network bits 25 means I can specify the CIDR as /25. Network bits 25 means I can simply calculate there are first 3 octets going to be completely full, which I can have 255, 255 and 255. The remaining 1 bit, which means 25 minus 24 equals 1. This 1 bit is borrowed from the 4th octet. If you borrow 1 bit in your subnet mask, you can specify it as 128. You can refer the chart I have given earlier. So here, if you borrow 1 bit, you will have 128. If you borrow 2 bits, you will have 192. 3 bits means you will have 224. So likewise, here, for example, if I'm having /22, how I can write the subnet mask? First 2 octets, which means 8 and 16 are complete. So for the first 2 octets, I can mention 255.255. So the remaining bits, 22 minus 16 will give me 6. So the remaining 6 bits have been borrowed from the 3rd octet. If you borrow 6 bits, you can refer the chart again. 1, 2, 3, 4, 5, 6. 6 bits borrowed means 252. So you can have the value 252 here, and you will have all 4 octets in subnet mask. So the remaining octet will be host portion, which you will mention as 0. Okay. So if you understand this concept, try to write subnet mask for /18 and /15 and /27 and /30. Okay, /18, 15, 27 and 30. Write subnet mask for each of these and practice. So in our IP question, our NH portion has been done and subnet mask portion has been done. Next, I wanted to figure out the multiplier, NH mask multiplier. Okay, so how many addresses I'm going to have, or how the subnets are going to be increased. Multiplier. In order to find the multiplier, you need to know what is the subnet mask. So here I am having the subnet mask of 255.255.255.128. So to figure out the multiplier, you need to first find in which octet the last change has been happened. You need to figure out in which octet the last change has been happened. So here in this question, the 128 is the last change. If the 128 is placed here in the third octet, the third octet will be the last change portion. Okay, so in this case we are having it as the fourth octet. So in the fourth octet, you must deduct the 128 value from 256. 256 is a constant number of total IPs you will have in your octet. So that is why we are reducing the value from 256. Okay, so 256 minus 128 will give you 128. Okay, so this is going to be your multiplier. Okay, so our third portion is also done. We found the multiplier, which is equal to 128. Okay, for example, if you are having 224 here, you need to again minus 256 minus, you need to again minus 224 from 256, and the answer is going to be your multiplier. Okay, so now we found the multiplier, and we know our IP address is 172.16.0.0/16. Now the IP address changed 172.16.0.0/ the subnet mask, which is 25. Okay, and I need to write the second subnet. This is the first subnet, which is named as subnet 0. Okay, network address is this. Okay, the first address is called the network address. The last address of the subnet is called the broadcast address. I will have a broadcast address written later. So below I am going to write the network address of subnet 1. Okay, so how can I write the subnet 1? Here you found multiplier is 128, and the 128 is going to increase on the fourth octet. So here the fourth octet is this portion, so this is going to increase by 128. So in the fourth octet you will write 128, and all the remaining octets going to be the same. So 172.16.0.128/25 again. Okay, so which is the network address of subnet 1. Okay, again you will have a broadcast address, which is the last address of this subnet, and then you can find the network address of subnet 2. So how you can figure out? So now let's have a look at broadcast addresses. So if I am having network address of subnet 1 here as 172.16.0.128, the previous address of this will be the broadcast address of subnet 0. So how can I find? If it is 128 here, the 127 will be my broadcast address of subnet 0. So simply I can write 172.16.0.127/25, which is the broadcast address of my subnet 0. Then again, for subnet 1, the broadcast address, I need to add 128 here. So if I add, I will get 256. In any IP, you can't write 256. So the 256 is going to be the second subnet, which means subnet 2. And if you get 256, how you will write? 1.0, which means 172.16.1.0, because you can't write 0.256 like that. Okay, the 256 portion changes after passing 255. You will change it into 1 and 0. Okay, so that's not that much needed now. So we can focus on the broadcast address. So if this is 256, the broadcast address of subnet 1 will be one address prior to this 256, which will be 255/25. So you can complete by 172.16.0.255/25. Okay, so this is the broadcast address of subnet 1. Okay, so throughout our calculations, we have done NH, the first portion, then mask, the second portion, then multiplier, third one, and networks. Now, writing the subnets is our network portion. Okay. Likewise, you can practice the remaining questions. For the same IP address, 172.16.0.0/16, try to answer for 14 hosts per subnet and 59 hosts per subnet and 400 hosts per subnet. I will explain this in another session. In the next session, we might do the next calculation as per subnet requirement. For example, minimum 40 subnets or minimum 65 subnets, like that also we will do in the next upcoming sessions. If you like the videos, please like, share and comment so that I can spread my knowledge in a larger scale. Thank you very much.